name is Ayman Hussein, and I am the director of 3D printing at Alquist. Here at Alquist, we focus on printing homes that are affordable in the community and for the people in the area. We range between 1,500 square feet and 1,300 for our single family. We use large-scale construction 3D printers to be able to create affordable housing in rural and unserved areas. So when we arrive on site, we typically work on a slab or a ribbon footing, and what we do is we set the printer up around where the house is going to go. We typically have around 5 or 6 pieces of equipment, and that is printer, and we also have a control panel to operate and monitor the print settings. Then on the material side, we have a silo which holds the dry material, and directly below that we have a mixing system and a pumping system. The water is added in that process and pumped through a hose, which then feeds the printer material. This process isn't very different than a typical desktop 3D printer. What you do is you start your design stage and you create a CAD file that basically tells the machine where to go and how fast to do it and how much material to let out at that specific spot. And so the program is the center line of where the nozzle is, and the printer will follow that line throughout the whole process. The way the printer reads, it's a cross section. So if you were to draw this up and you cut out a very thin line of that object, that's what the machine sees, and it sees a bunch of those over and over and over again to complete the house. The two rails, if you will, those provide your outer bounds for your wall, and so in that middle portion is where you can run electrical, your plumbing. In a sense, we are like a framing company. However, we're much more of a hands-on system where we construct all the walls and then we guide the GCs to install the doors, windows, HVAC, and plumbing systems. You're doing the house and you have to leave cavities for your 2 doors. What happens is it kind of splits that house into 2 wall sections, left of the door and right of the door. And what it'll do is it'll do that wall section, it'll lift up, go to the other side of the door, and complete that other wall section. And then once you're at the top of the door, what we do is we add I refer to it as a manual support. And so what we do is we add a steel lintel that stretches across that window or door, and then the printer then continues printing directly over top that system. Each house consists of around 150 layers. Each layer is approximately 3/4 inch thick, and so that makes a standard 9-foot wall. Based on our current mix design, each layer takes around 5 to 10 minutes before we add another layer on top of it. So that's like the layer set time until it's hard enough to be able to hold weight for another layer to be added. And then we try to hold off for around 2 weeks before any large load-bearing weight, such as a roof system, be added, and a concrete reaches the max strength at 28 days. Nozzle design is really customizable, especially in the 3D construction industry. There's the squared off nozzle where it has a flat aesthetic, and then there's the rounder nozzle that leaves a more of a bead look. They have the same properties as far as structural design. It's more of an aesthetic finish. With the printed system, if you wanted a more structural or more ballistic based wall, you can increase the concrete in that wall system by increasing the nozzle thickness. What we have is on this specific nozzle, the back end of the nozzle has a raking system, and so as it goes, it provides those grooves, and so that's just an indicator of making sure you're at that right height, and allowing the next layer to smooth it directly over top. The process, the way it's done, very similar to a bricklaying system, where you would go around and you do 1 layer of bricks, and then once that layer is finished, you go to the next one. It's very similar in that process. However, the building materials and the labor-intensive portion of that is obviously different. 3D printed homes allow for quicker construction that are also less expensive and more durable over a long period of time. Since we have those 2 whites, all our homes are considered thermally broken, which allows for less utility cost to maintain the home. One of the main questions that I get on my TikTok or personal interactions is the replacing of manual labor and people leaving without jobs. And that's what I address that here is this technology we see as the answer to and not the cause of the national job shortage. We are committed to locally hire booster runner machines. So if we go into a community, we hire from within that town, train them on the printer, and they become our print crew in the area. And just like any automation company, it's our duty to replace any jobs lost through the process. And so we are working with a lot of universities across the country to create a job force development program to train people on this new system in this very new industry.